Good morning or good afternoon, depending upon when you are watching this video during the day. This is going to be your lesson all about 3.6, and in 3.6 we're going to continue to work on constructions. Now recall from chapter 1, a construction is something that we can create using only a compass and a straight edge and a pencil. Now that means you're going to have to make sure you have those tools in order to do this lesson as you are watching the video. Now, before you do the video, I hope that you've already completed the 3-7 and 3-8 warm-up number 1. We'll take a look at those results together in class tomorrow when I return. After you've taken care of the notes for 3-6, as you can see, I'm going to ask that you do the vocabulary support assignment available to you on Schoology. Homework this evening, you have 3.6 Math Excel. It is 14 questions long. I do ask after this assignment that you get started to work on your Chapter 3 test review. Because it is 8 sections that we're testing on, this review is a bit lengthier than normal. Per usual, if you have 100% on all of your Math Excel assignments, you do not need to complete this. Let's get going. All right, so the very first construction that we're going to do today is we're going to construct the perpendicular to a given point on a line. So I've been given point P, and point P exists on line L. So I need to construct line CP such that line CP is perpendicular to line L. Now, if you recall with a straight edge, you can only put your straight edge needle on points that have already been defined. Therefore, the only point that has been defined is point P. So what I'm going to do first is I'm going to place the needle on point P, and I'm going to have it be open such that when I create an arc on the line, it doesn't go off of my line. So I'm going to create an arc to the right of P, and then I'm also going to create an arc to the left of P. By creating these two arcs, what I have just enabled for us is to have two more firm points defined. So I've now firmly defined this point here and this point here. Because new points have been firmly defined, I can now place the needle of my compass on these 2 points. So I'm now going to take the needle of my compass and place it on the first point. Okay, so here it is. I'm probably going to need to open up my compass a little bit more at this time. So when I open up my compass, it's pretty sizable, it's pretty large. But I know that it's going to, when I create an arc, it's going to extend beyond point P. So as you can tell over here, my arc is extending beyond point P. As we've discussed before, it's extremely important that you maintain how wide open your compass is. So now when I move my needle to the other point, this other red dot, and I create an arc off of this, when I create the arc off of this point, notice that the two arcs intersect. Okay? Once again, this creates another firm coordinate for us. This is going to be our firm point. Okay? We now can utilize our straight edge, and we're going to take our straight edge. So once again, I obviously do not have a straight edge, so I'm going to have to go at it with my board here. And with my straight edge, I'm going to draw a line through point P and through this new point that I have firmly created. So here is my line. And the only thing I'm missing now is just finishing up my labeling. So I'm going to label this other point that we created C. So now what I have created is a line CP such that CP is perpendicular to L. So if I really wanted to, I could add in that little right angle symbol. All right, that is the first construction that you are expected to do. Your GATA question says that you're going to do the same construction. So at this time, you can either pause the video or just like we did in Chapter 1, you can actually do all of your GATA questions at the end. No matter what, you should be able to produce something that looks like this. Obviously, this is a computer-generated image, but your construction should look identical to ours. All right, so now I'm going to give you another postulate. This will actually be your last postulate for this chapter. Woohoo! Postulate 3.3 is also known as the perpendicular postulate. And what it says is, I only have the ability to produce one line that is perpendicular to L going through this one point P. So here's point P, and I only can draw one way through that point P such that it is perpendicular to line L. It is thanks to this postulate that I'm actually able to do the next example, okay? But my big takeaway, I'm going to highlight this for you. that I need you to understand is that there's only one line that you can draw through this line L that also goes through point P, such that these lines are perpendicular. So in my second example, notice I have line L and I have a point R that is existing off of line L. And my job is to create a line going through R such that it's perpendicular to line L. As I've already discussed, all I can do is place my needle on already defined points. The only defined point in this picture is the point R. So what I'm going to do is I'm going to make a very sizable arc here. I'm going to create an arc that intersects this line. Essentially, it's kind of like a tri-circle. It's not a semicircle, it's part of a circle. But when I create this arc off of R through line L, what I have just done is I've intersected now in two locations, creating firmly defined coordinates. So here is a point, and here is a point, okay? Because I have created these points, I now have the ability to place my compass on more points, okay? So I'll change my color here. So now my compass needle is going to go on one of these newly defined points. And once again, I'd like to have my compass opening pretty wide here, such that it's open to about more than the distance from that point to R, okay? So I'm going to create another arc right here. And this is going off of that first purple point that I had created. And maintaining that opening, I'm now going to make another arc off of the other side. So when I do that, notice that these two arcs that I just created have intersected. So once again, this means it is a firmly defined point that I have created. Now I'm going to take my straight edge. And like I said before, I don't really have a straight edge. I have my board here. And I'm going to draw a line that goes through R and through this red dot that you and I just found that we just created, okay? Now, according to the question, I wanted to create a line called RG. So I'm just going to finish up this problem by naming this red coordinate here G. And that is my line RG such that RG is perpendicular to line L. So the first two constructions that we've done in the 3-6 lesson both dealt with perpendicular concepts, okay? So the guided question is doing the exact same thing. I want you to construct a perpendicular line through a point that is not on the line. So as I said before, if you'd like to pause the video and do the got it now, that's fine with me. Or you are more than welcome to take care of this got it question at the very end. No matter what, your got it question should have an answer similar to mine right here. Okay? So perpendiculars are not all that bad. The constructions that prove to be a little more difficult in this particular section are the next two. In example 3, what I'm going to do is I'm now going to construct a parallel line through point N, which is not on line L. And this parallel line has to be parallel to line L. So there's a lot of steps to this particular construction. So I want to encourage you to pause the video as you need, rewind the video as you need. This is your opportunity to learn at your own pace. So the first thing that I need to do is I'm going to take my straight edge, okay? And my straight edge is going to allow for me to create a line going through line L and the point N, okay? So what I've just done essentially for myself, just looking to the future here, is I've created a point right here on line L, okay? We'll call this point A if you'd like to. Now, what I have done for myself essentially is I've created an angle, okay? And what I'd like to do is I'd like to create this angle up here as well. Because when I do this, I'm going to have angles that are congruent to one another. And these particular angles are going to be corresponding angles. And this assures me that my lines will be parallel to one another. Okay? So what I actually need us to do is recall from chapter 1 how to construct congruent angles. So what I'm going to do is I'm going to place the needle on A, okay? And I'm going to create an arc off of A going through line L and through the other line that I've just created. So it's gone through two places. I'm now going to move my compass needle to N, and I'm going to create another arc, maintaining that opening, And once again, I got to make sure that it goes through the line on the top as well as gives me some space below. Now, if you recall, the next step to constructing congruent angles was to opening your compass mouth to being the distance of your opening. So notice that I've just lined up my compass needle and pencil, and it actually is already the same width of the opening of the angle that I've created, okay? So I'm now going to carry that over to this up here, okay? So my needle is actually on the top green line arc where it intersected with that line, and I'm going to create an arc off of this. Once again, I'm not using N because I've already used up N at this time, okay? So now, this little intersection point right here, what this has actually provided for me is another point that I've gone through, okay? So what I'm going to do with that is I'm going to finish up the problem here. I'm going to take my straight edge, and I'm going to go through N through this point. Now, obviously, it's not perfect here because my dots are really, really large, but it's a pretty good attempt here, okay? So this is my line. Lines obviously have arrows, so I should probably make sure mine has arrows, and I'm also going to want to label it appropriately. So here's my arrows. And according to the question, I was supposed to name it M, so I'm just going to, off the side here, do my little cursive M, okay? So the guided question for you here is actually not a construction. However, I do want you to also verify that you know how to do this construction all on your own, because your ability to practice this is not successful in Math Excel because you're not doing it with your hands. You should know how to do this for your test on Thursday. So it says, why must lines L and M be parallel? So what I want you to think about here is, what did I just guarantee was true? Essentially, I just constructed congruent angles, and what type of angles were these? Well, hopefully you just thought about it and you realize that they're corresponding angles. So what I basically just showed you is if corresponding angles are congruent, then lines are parallel. This is all thanks to the converse of the corresponding angles theorem. All right, so for my last problem, I'm going to amp it up just a tiny little bit here. My last example says I need to construct a quadrilateral that has one pair of parallel sides, and they need to have lengths of A and B, okay? So the first thing I need to do, well, I need to do a lot. So I first need to give myself the base of my quadrilateral. So I'm going to just draw with my straight edge a line, okay? And then I'm going to recall how to construct congruent segments from chapter 1. So I'm going to move my needle and I'm going to place the needle on one end of A. And I'm then going to open up the mouth such that it's now the width of A. So now when I bring my compass to my location over here and I create my little arc, what I have just guaranteed so far is I now have the length of A. Okay? This guy here is the length of segment A. I'm going to call this coordinate here A. And this is also now another point. Okay? Because ultimately here it says I have to name my quadrilateral A, B, Y, Z such that AZ is the length of A, I'm going to name this other coordinate here Z. Okay? Now the next piece, because I've already established my firm size of my base of my quadrilateral, the next piece that I want to do is I want to do the parallel construction such that the top is parallel to the base. So I'm going to do the same construction that I just did. I'm now going to take my straight edge and make a line going upwards from A. Okay? So now what I have just done is I've given myself kind of a blank slate. And unlike my previous construction, I now need to give myself point B. So there, we're going to name this guy here point B. Okay? All right, so now what I'd like to do is I'd like to ensure that whatever length I produce, whatever line I produce, it must be parallel to AZ. So what I got to do is the steps that I just took in order to ensure that my angles were congruent in the first problem. So what I'm going to do is I'm going to flip over my compass here, make sure it's opening up, okay. All right, so now I have my compass, and I'm just going to make it a little smaller here. I'm going to take my needle, place it on A, and create an arc that goes through AZ and through AB. Maintaining this opening, I'm now going to move the needle to B and also create an arc off of B. Now notice I kind of sketched myself out a little bit here, a little worried about that. This top part of where my green arc intersected, do you notice that it really came close to not intersecting with this black line that I made for AB? That's just my warning to you, because I also just almost made this mistake. You should probably make that line really big. Now, I was fortunate enough that I could just change it here, but I'm not going to. I'm going to have my experience and help you learn from your mistakes, okay? All right, now, the next piece to creating those congruent angles is making my compass the same opening. Oh, and I got really lucky here again. So now it is the opening of this angle here, and I'm going to bring my needle to that top green arc piece, create that intersection. Voila, voila, voila. Oh, that was a much better one than my last parallel line. With my straight edge, I go from B through to that intersection point, and I'm going to extend this really, really far here. It doesn't look very straight though, if you ask me. There, that's better. And now I just need to finish up and tie up my loose ends. The last thing I got to do is make sure that this top piece of my quadrilateral is the same length as B. So I'm bringing my compass over here, opening it up to the length of segment B. I'm then going to bring that length, maintaining the length, maintaining the opening. I'm going to change the color of this so that's a little less confusing. I'll make it yellow. Create my little arc off of this, and what I have just done is I've established my next coordinate. And according to the directions, I was creating segment BY, that was the length of B. This guy right here must be Y. And then, to finish it up, I'm going to take my straight edge and connect Y and Z. Now, I didn't say it was going to be a pretty looking quadrilateral, but this is indeed a quadrilateral. I'm going to highlight for you the inside of my quadrilateral. Here is the inside of my quadrilateral A, B, Y, Z. I'm taking my time here. Like I said, this is definitely the toughest of the constructions, so you definitely want to use this time if you need to rewind or hear something again to make sure you got and saw the construction. Your last guided question is going to have you do the same thing, except for the fact that with your side CD, I want it to be double the length of its base M, okay? And then there's also a reasoning question for you to think about. I'll talk through the reasoning answer now, but you can also pause the video and take your time to make sure you understood the construction. So it says, suppose if you and your friend both use the steps in problem 2 to construct, not problem 2. I changed this, by the way, from last year. I made this problem 4 because I figured this was the most difficult construction, so we should end on it. So problem 4, to construct this ABYZ independently. Will your quadrilaterals necessarily have the same angle measures and side lengths? No, explain. So no, because ultimately I was the one who created this angle up here. So my friend and I definitely can't guarantee that it's going to be the same, which means we ultimately can't figure out how long this piece is going to be. So we're all different, and all of our quadrilaterals are going to be different, okay? Well, that is your lesson video for 3.6. Congratulations, we've just finished Chapter 3. After you finish all your guided questions, I do ask that you now complete the 3.6 vocabulary support, and as time permits, you may start to work on your Math Excel, or perhaps you want to finish up any of those classwork assignments from last week. I look forward to seeing you when I return tomorrow. Have a great evening.